Good morning, children. We'll see the ninth chapter in this video. The ninth chapter is force and laws of motion. This is the second chapter in your for physics in your ninth standard. This talks about force and laws of motion. So we already learnt about motion, right? So in the first chapter we learnt about motion. We learnt about various other topics related to the topic motion. But what causes motion? We all know that we need to give a force in order to cause a motion. So what is a force? A force is nothing but a push or a pull of an object. So a force is nothing but a push or a pull of an object. So force is something which is an external effort, okay? So which is something from outside, okay? And what all does this force do? This force may move a body at rest. That means if an object is going to be at rest, maybe it can move that body, or it can change the direction or shape or size of the body. So all this will happen due to the push or the pull of an object. So here you can see this person is first giving a smaller force, and the boy on the skateboard has moved to a lesser distance. Now he is going to give a greater force, due to which he is going to move to a greater distance. So we are able to see different effects of force. Next we will learn about the types of forces. There are two types of forces. The first one is the balanced force, and another one is the balanced force, unbalanced force, which you would have learnt in your 8th standard already. So the two types of forces are your balanced force and your unbalanced force. We learn about these two in detail. So balanced force and unbalanced force. So balanced force is something wherein the forces are going to be equal, okay? They are going to be equal and opposite. So here you can see in these pictures that the forces are equal, but they are opposite in direction. So balanced forces are equal and opposite in direction, whereas unbalanced forces are unequal. Direction also you do not know. They might be equal or they might be opposite, but they are unequal in size, okay? And balanced forces will not cause any change in the object. The object will not change. But when you give an unbalanced force, the object will change its position, okay? The position of the object will change in the case of unbalanced force. Here we are able to see different examples for balanced and unbalanced forces. Here you can see, so when you have a balanced force, you are able to see the values are the same in both the sides. Both the sides is going to be equal, but they are opposite. When there is unbalanced force, we are able to see that they are unequal. Direction will vary. It might be the same direction, or it might be in a different direction. So here you can see different cases for balanced forces. So due to the balanced force only, we are able to sit on a chair. If not, we might fall down. Here you can see for unbalanced forces, the values are changing. So you can see this very much in a tug of war. When you play the tug of war, you will be able to see that because of the unbalanced forces, the people will be pulled towards one direction, or people will be pulled towards one side of the rope. And even here you are able to see that the birds are flying in the air because of these unbalanced forces. They are able to move against the air friction. So here you have the comparison between the balanced and the unbalanced forces. Next we are going to learn about the laws of motion. Here we are seeing three people. So who are these three people? Aristotle, Galileo Galilei, and Sir Isaac Newton. We learned that all these three people took about 2000 years. That means what? Each of them during different periods of time, they worked on the same concepts building one upon the other, and thus they were able to develop a relationship between force and motion. Okay, listen to what I'm going to tell you very carefully, children. I want you to give the activity based on this. Okay, so the activity is going to be based on the small story which I'm going to tell you regarding Aristotle, Galileo Galilei, and Sir Isaac Newton. Okay, so Aristotle, he first had a thought about motion of objects. So he said that we need to keep giving a force to keep an object in motion. So if an object has to keep on moving, he said that a force has to be continuously given. But that is not true. We know that if we want to keep an object in motion, if we just give a push, even then it will move for a certain amount of time without anybody going behind it. So this is what Aristotle said. So Aristotle told that we need to keep giving a force. So then came Galileo Galilei. So he said that no, what Aristotle told will not hold good for all surfaces. What Aristotle told will hold good only for surfaces where they have very less, that is, they have more friction. Okay, they have more friction. So, or you can say a rugged surface. So he did not consider the frictionless surfaces. Aristotle did not consider the frictionless surfaces. This was told by Galileo Galilei. So next came Sir Isaac Newton. Okay, so what did Sir Isaac Newton say? He developed the concepts of Aristotle and Galileo Galilei, and he gave out the laws of motion. He gave out 3 laws of motion, which is what we are going to learn now. Okay, so all these were brought about by these 3 people, and it took nearly 2000 years to develop the relationship between force and motion. So now your activity is to write the contribution of any of these 3, or you can summarize all the contributions of these 3 as a write-up in a paper, sticking pictures of these 3 people. Okay, so you can either stick pictures of these people and write give about a contribution about these 3 relating to the laws of motion. So this is one. If you want to do a model apart from the write-up, if you feel you don't want to do a write-up, but if you want to do a model, then you can give a model with a friction surface and a frictionless surface, depicting how a force is continuously required for a frictioned surface, whereas it is not required for a frictionless surface. So this is your activity for the first term. So here we are seeing the friction concept. So here you are able to see the frog which has hit the ball. The ball went and it came and stopped. Now see, when the ball is going to come and stop, the frog is going to move away, but still the ball has stopped. Why? Because of the friction. Okay. Though there is nothing to hinder the movement of the ball, but still the ball has stopped. Why? Because of the frictional force given by the ground. So what is friction? Friction is a resistive force caused by 2 surfaces sliding across each other. When you throw anything or when you move anything, you can see that there will be a frictional force acting opposite to the direction of motion. So this is your frictional force. So your second activity will be based on the frictional force. So you can do either of these. You can either give a write-up pasting pictures of these scientists, or you can do a model depicting the frictional force, because this is going to give us the laws of motion. So here you can see different objects moving with different speeds because of their shape, because of their size, because of the material with which they are made. Next, we are going to learn one more new word called inertia. So what is inertia? Any object which is in motion, it will have a tendency to be at rest. Okay. So for example, if this cat is going to sleep, the cat will want to sleep. So if you're all going to keep sleeping, you don't want to wake up immediately. So your tendency will be to be at rest. Okay. Or else if you're going to keep running, okay, you always want to keep running, so you will feel that you want to run. So here you can see, so this small toy, okay, it is loaded with a small cart loaded with some objects. Okay, so when it is going to keep moving, the objects are also going to keep moving, but it is coming to a rest. Okay, but still the objects tend to move. The objects are not ready to stop immediately because of inertia of motion, because they have a tendency to preserve its state of motion. So the tendency of an object to stay at rest or preserve its state of motion is called inertia. So here you can see different objects have different inertia. So if it is going to be a smaller object, it is going to have lesser inertia, and a bigger object will have more inertia. It is more easy to push this boy than to push this boy, because this boy is little heavier than this boy. Likewise, a man will have lesser inertia when compared to an elephant. Now we have three types of inertia: inertia of rest, inertia of motion, and inertia of direction. Inertia of rest says the object tends to remain at rest. The object doesn't want to move. So inertia of motion means, still, see, the person, once he is stopping, he is not able to stop immediately, but he still keeps moving. When you get down from a bus, okay, which is slightly in motion, you cannot stop immediately. You will move for some distance and then only stop, because of inertia of motion. Here in inertia of direction, now you will be able to see a car moving. Okay, you will be able to see two people. So as the car is going to take a turn, you are able to see the two people moving towards one corner, because of the inertia of direction. So inertia will keep a moving object to be moving. Okay, it's only friction force which will stop the motion of the object. Okay, it is not inertia. Inertia will say a moving object will continue to move, or an object in rest will continue to be in rest. Okay, here you can see. So when he is going to start, he is going to move little back, and when he is going to suddenly stop, we tend to move forward. You might have seen this while traveling in your car or bike or your bicycle. Here you have different examples for inertia of rest. Okay, so when that board is pulled, you are able to see that the ball is still wanting to be in rest, so it just falls into the cup of water. Here you are able to see inertia of motion. The people who are going, you are able to see that the vehicle stops, but the people still tend to be in motion. Here you can see the ladder still tends to be in motion. That is why the ladder is falling down. Okay, here also you can see that the apple which is there in the skateboard is still wanting to move, okay, because of inertia of motion. Here you can see the person who tends to move forward because of inertia of motion, though the car has come to a stop. That is why we feel a jerk when brakes are applied, and that is the reason we are all asked to use the seat belts, because the seat belts will protect us and save our lives when sudden brake is applied. Here you can see the inertia of direction. The people are moving towards the corner. Okay. Next we'll get into the laws of motion. The first law of motion is also called law of inertia. The first law of motion is also called law of inertia. The law of inertia states that an object will remain in its state of rest or uniform motion. So this is the concept of inertia. Okay, in a straight line unless compelled to change that state by an applied force. That means we are giving an external unbalanced force. Okay, an object which is at rest will be at rest unless an external unbalanced force is going to act on it. Okay, so only when you give an unbalanced force, the object is at rest will move, or an object in motion will stop. So here you can see an object remains in a state of rest or uniform motion unless compelled to change by an applied unbalanced force. Okay, so only then the object will move. So even here you can see only if you are once you kick the ball, so it is going to keep moving unless you have an external frictional force acting on the ball. So here you can see the dog was in motion. Though it tried to catch the ball, it still had to topple over because of its inertia of motion. So force keeps a thing moving. So that is what was told by Aristotle. So Galileo Galilei said that no force will either stop or change the direction. So what will keep a thing moving? It is inertia which keeps something to be in motion. Likewise, it is going to be a frictional force which will stop. So now we are going to learn about the relationship between inertia and mass. Mass and inertia are directly related. Okay, so mass is the quantity which solely depends on inertia. So little car or a normal car will have lesser inertia than a bigger truck. It is easier to move a car than to move a truck. So you can see different examples here. Okay, so if you want to push an empty bucket, it is very easy than to push a bucket filled with sand. Likewise, an elephant will have more inertia than human because an elephant has more mass. Here also you can see it is easier to push an empty trolley than a trolley with goods because this will have lesser mass, lesser inertia, more mass, more inertia. So we learn that heavier object will resist moving. Likewise, it is also difficult to stop a heavier object which is already in motion. Now we will get into the second law of motion. So to learn the second law of motion, we need to learn about momentum. For the first law, we learnt about inertia. For the second law, we are going to learn about momentum. Momentum is nothing but movement. You should remember the word movement. So what is this momentum? Power of a moving body. If you want to keep an object in motion, so what all do we need? First of all, the object should have a mass. The object should have a mass. Okay. The next thing is that if an object is going to move, the object will possess some velocity. The object will possess some velocity. So this is the second thing. Okay. The first thing is that the object will have a mass, and if it has to move, the object will have a velocity. Okay. The momentum is the product of the mass and velocity, that is P is equal to mv. P is equal to mv. So momentum has both direction and magnitude. So m into v, the unit of mass is kilogram, the unit of velocity is meter per second. So SI unit is kilogram meter per second. The SI unit is kilogram meter per second. Okay. Here you can see that the momentum will increase when either the mass or the velocity is increasing. It does not mean that both should increase. If either of these increase also, the momentum will increase. Sometimes the mass will be less, velocity will be more. Sometimes the mass will be more, the velocity will be less. Okay. If either of them increase, then momentum will increase. We'll see with a small example now. So here you can see two objects. So one is a larger object and another one is a smaller object. Okay. So a larger object, you can see it has a mass of 100 kg. Okay. So it has a mass of 100 kg and the small object is having a mass of 10 kg. But you can see that though the velocity is less, the mass is more, so the momentum will be 1000 kg meter per second. 1000 kg meter per second. But here you can see, though it is a smaller object, the velocity is more, but still the momentum remains the same. So here you can see that both have the same momentum. So here you are able to see a numerical relating to momentum. So what will be the momentum of an object having a mass of 2000 gram if it is thrown at a velocity of 50 meter per second? Okay. So here we are given the mass and the velocity. We are given the mass and the velocity. We are asked to find out the momentum. So what is momentum? Momentum is equal to mass into velocity. Momentum is equal to mass into velocity. So what is this momentum? P is equal to m into v. So here the mass is in terms of grams. So we are converting it in terms of kilograms. So it will become 2 kg. It will become 2 kg. Now you have the velocity in terms of meter per second. So you're going to get it as kilogram meter per second. How much kilogram meter per second? 100 kilogram meter per second. See the next one. Here you are able to see another numerical where you are able to see how much momentum will a dumbbell of mass 10 kg transfer to the floor if it falls. Carefully listen to the word if it falls. If it falls means it falls down automatically without any external force. That means the initial velocity is 0. The initial velocity is 0. So height is given. That talks about the distance covered. So it is 80 centimeter. So we are converting it into 0.8 meter. Okay. And then downward acceleration. That means the acceleration is along the motion. So it is positive. So it will be 10 meter per second square. So now they are asking us the final momentum because momentum which it would transfer to the floor. So they are asking us the final momentum mv. Okay. So the formula is what? B square minus u square equal to 2as. Okay. So we are using this formula because we know u, we know a, we know s. We don't know v. So by using this equation of motion, we will find out v is equal to 4 meter per second. So by using the value of v and by using the value of the mass, we can find the final momentum to be 40 kg meter per second. So now we'll learn about the second law of motion. I told you the second law of motion is related to the momentum. So here we are learning about the rate of change of momentum. We are learning about the rate of change of momentum. So second law states that the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. That is, we are considering an object of mass m which is moving along a straight line with an initial velocity u. Okay, so it is uniformly accelerated, and when you have acceleration, there is a final velocity v. There is a final velocity v, and the time taken for the velocity to change, for the acceleration to happen, is going to be time t. Okay, so this is the consideration to derive the second law of motion. Now we have various parameters which we already know. Okay, the mass of the moving object is going to be m, the velocity is going to be from u to v, that is the initial velocity is u, the final velocity is v. We know that momentum is mass into velocity. So here we have a change in the velocity, so we have a change in the momentum. So initial momentum is going to be mass into initial velocity, and the final momentum is going to be mass into final velocity, that is mv. Initial momentum is mu and final momentum is mv. Now we will find out the change in momentum, because the second law states that talks about the rate of change of momentum. So first we need to know momentum, then we need to know change in momentum. So change in momentum talks about Pf minus Pi, that is final momentum minus initial momentum. Okay, so your final momentum is mv and initial momentum is mu. So it is m into v minus u. Okay, so what is the rate of change of momentum? We already learned that wherever we have the word rate, we will have time in the denominator. Wherever we have rate, we will have time in the denominator. So here it is rate of change of momentum. So it is change of momentum divided by time. Okay, so now it is going to be m into v minus u by t. v minus u by t. Okay, so here we will be having the rate of change of momentum. Okay, so we learned that the rate of change of momentum is directly proportional to the applied force. It is that proportional to the applied force. Okay, so now we have to find out what is force also. Okay, so from here we know v minus u by t is what? A. Okay, so we have m into a. So rate of change of momentum is going to be m into a. We know from the Newton's second law of motion that force is directly proportional to the rate of change of momentum. So F is proportional to ma. So to remove the proportionality symbol, we introduce a constant k, because the proportionality symbol says that these values are changing by a constant. So here this constant is k. F is equal to k into ma. So the k value is 1. Okay, after a lot of research they found that k value is 1. So when you substitute k is equal to 1, we are getting k is equal to ma. We are getting k is equal to ma. So now force is equal to mass into acceleration. So force is equal to mass into acceleration. So this will be the formula for the second law of motion. So this will be the formula for the second law of motion. So F is equal to m into a. You will have to remember this. Okay. Now we'll learn the applications of the second law of motion. We will learn the applications of the second law of motion. We have two applications given in our textbook. Okay, the first application is regarding the cricket player. Okay, so whenever a cricket player tries to catch a ball, we are able to see that he has to lower his hands. Okay, so only when he is able to lower his hands, we are able to see that the momentum will become lesser. Okay, so because of the acceleration, it will get reduced. So if he is going to lower his hand, and there will be lesser force which will be applied to stop the ball. Okay, there will be lesser force which will be applied to stop the ball, so that there will not be any injury caused to the hands of the player. Here we have the next application. So this application talks about an athletic event. Okay, this application talks about an athletic event. Okay, so here you are able to see that whenever you have a high jump, okay, so even we would have seen in even in our school sports day, you would have come across these things. Okay, you would have come across the sand bed. Okay, have you come across this sand bed? Yeah, they'll use it for high jump and long jump. Why? To increase the time of the athlete's fall. Okay, because if he's going to just fall on a strong floor, you know what will happen? He'll hurt himself. Okay, so now if he's going to have a cushioned bed, then it will give a lesser force, so it will reduce the rate of change of momentum. Now what is this force? F is equal to m into a. So 1 unit of force is what? You know, the unit of mass is kg, unit of acceleration is unit of acceleration is meter per second square. So unit of force is kilogram meter per second square. The unit of force is kilogram meter per second square. So unit of force is going to be with a constant k, so that will become 1. So 1 unit of force is defined as the amount that produces an acceleration of 1 meter per second square in an object of 1 kg mass. In an object of 1 kg mass. So this is 1 unit of force, and this is also called Newton. This is also the definition of 1 Newton. Now we'll learn the second law of motion. Now we will learn the second law of motion, third law of motion. Okay, we have learned the second law of motion. We are going to learn the third law of motion. So third law of motion is a very easy law. It says that for every action there is an equal and opposite reaction. For every action there is an equal and opposite reaction. Okay. So it can also be said like, when one object exerts a force on another object, the second object will exert a force back on the first. Okay, when you get down from a boat, so when you exert a force from the boat onto the shore, there is another force exerted by the leg again on the boat. Okay, they act on different objects. So likewise you are able to see even in a gun. So in a gun you can see that you are going to use the trigger to give a force, and on the other hand the bullet is going to keep moving in the forward direction. Okay, see here, for every action there is an equal and opposite reaction. For every action there is an equal and opposite reaction, and remember that they act on two different objects. So here you can understand it even more clearly. Okay, so your leg exerts a force, a push on the floor, whereas the floor will exert a push on your leg. That is why our leg will also come up. Okay, so this is how even we walk. So we have to walk in this motion only, where you have action and reaction being involved. We will see different examples. Children, I have different pictures showing different examples. Okay, so you can see moving from the boat. Okay, action is the boy's feet exerting the force on the boat, and the boat will also exert a force back. Okay, likewise while walking, and even the gun. So here you can see you are able to sit because the chair is exerting a force. If not, we would fall down. Okay, likewise the rocket, so rocket which is moving up, you are able to see the gas which is gushing down is an action, and the reaction is the rocket moving upwards. Even the bird which is flying, all these, here you can see that we are making a small rocket kind of thing with the help of the crackers. Okay, with the help of matchstick and all, they are going to make it, and we are going to place it on a toy car. Okay, so once you place it on a toy car and you try to ignite it, okay, you're going to try to ignite it, you will be able to see that the object will be moving. Okay, so you are able to see that it is going to keep moving, so it is getting ignited, and see the flame is going in one direction and the vehicle is moving in the other direction. So action and reaction are opposite, they work on two different objects. Okay, so it is going, the flame is moving towards one direction, whereas the vehicle was moving in the other direction. Here again you can see different pictures for action and reaction. Even when we push our finger on the wall will also exert a force on our fingers. Maybe we are not able to feel it, but it is there. Here you can again see a rocket picture. Here you can see again different pictures relating to action and reaction. Here you can see this, you would have done it in your 7th standard for the activity. So when you inflate a balloon and you just deflate it, just let it out, what will happen? The balloon will move in one direction, air will move in the other direction. So air rushes out is the action, and because of the air moving out, the balloon will move in the opposite direction. Even the same thing you can see here also with different pictures. Next is the final concept, law of conservation of momentum. Here we are learning that the momentum is going to be conserved. Okay, the momentum, we learned that momentum is nothing but the product of the mass and velocity. So here we are going to learn that this momentum is going to be conserved during the motion of the object. So law of conservation of momentum states that when an object exerts a force on another object, the second object will again exert a force back on the first object. Okay, they are equal in magnitude but opposite in direction, and you know that they will never act on the same object, but they act on the different objects. So for this law, to prove this derivation, we are considering two objects A and B of masses m1 and m2 moving with initial velocities u1 and u2. After traveling a certain distance, they collide and they move with velocities v1 and v2. They collide after a time t. The force exerted by object A on B is FAB, and the force exerted by B on A is FBA. Now we know that as per the third law of motion, FAB is equal to minus FBA, because every action has an equal and opposite reaction. So they are equal and they are opposite. Here we also know what is initial momentum, what is final momentum. Okay, we are considering for both the objects A and B. Likewise, we know what is change in momentum. Change in momentum is what? So change in momentum of object A would be change in the final momentum and change in the initial momentum. Likewise for object B. We know as per the second law of motion that the applied force is directly proportional to the rate of change of momentum. Okay, so we can find out what is FAB and what is FBA by using those equations which we learned from the second law of motion. My FAB will be m1v1 minus m1u1 by t, and FBA will be the m2v2 minus m2u2 by t. So we know that FAB is equal to minus FBA. Now that we have learned, we have found out what is FAB and FBA, you substitute in this equation and you know that T is the same in both the sides. You can cancel T, and by solving this you are finally able to come to a conclusion that the total initial momentum is equal to the total final momentum. Thus, the sum of the momenta of the two objects before and after collision are equal. That means the momentum of the two objects remains unchanged when there is no external force which is acting. There is no external force, only these two objects are colliding. Okay, there is no other force acting on these objects. So from this we can say that the law of conservation of momentum is proved. Here you can see this picture. So in this picture you are able to see that there is a container which is going to be attached along with this. First, this is going to be at rest, whereas this is going to be in motion. It is traveling with 10 meter per second. It will have some mass. Okay, so after it is going to collide, what will happen? It will still continue to move. The mass will increase, but the velocity with which it will move will decrease. Okay, the velocity will decrease, but the mass is going to increase. Thus we can say that the momentum will be lost by this object. Okay, but this object when rest will gain a momentum. Okay, so this will lose, but that same momentum will be gained by this object. Thus we can say that the total momentum will be conserved. So with this we are completing the chapter, children. I have completed the entire lesson in this video. I hope you would have been able to understand this. Please listen to the video and try to understand it. If you have any doubts, again get back to those concepts where you have difficulty. Okay, I'll also send you the solved NCERT exercise questions also. Please go through it and prepare well for your exams. Okay, so thank you, children.